Okay, great. So let's start. So welcome to this session. This is about mastering Kubernetes. This is a beginner-friendly session. If you are not aware of Kubernetes, no problem. There's no prerequisites for this session. Of course, if you are familiar with containers, if you are familiar with the Docker, if you are familiar with cloud native development, that would be a plus point. Uh, so we will be covering here the learning path. So we will be covering the roadmap of how to become a Kubernetes expert. There's a slight change in the agenda. So we were planning demo. Earlier we were planning demo on the Amazon cloud. Due to some urgent situation, our guest could not join today. So we'll be having that hands-on session next Sunday probably. So within a week, we will be arranging that hands-on session. But then I will be sharing you resources and a lot of other content which will help you to master Kubernetes and build microservices on your own, deploy it on Kubernetes cloud locally, process to run Kubernetes on any cloud, which is Azure or Google or AWS, will be very similar. So let's, without wasting further time, begin and cover the topics which we will be covering today. We will be diving into the fundamentals of Kubernetes. We'll be covering basic concepts and roadmap to how to get professional certifications and what are various certifications. And by the end of the session you will understand that you will understand definitely the fundamentals of Kubernetes, what it is, and how you can gain credentials which will be making you job ready in this field. So based on your role, I'll be helping you what certification you can do. So if you know you are a DevOps professional or a backend developer or a security professional, or just you are curious about Kubernetes and cloud native development, then you will get the roadmap and your appropriate path forward to master Kubernetes. So let me share some of the interesting agenda items which we will be having today. Will be understanding Kubernetes. It's written K8S because there are 8 words in between Kubernetes, K and S. So in short, it is also written as K8S. So we'll be understanding what are containers, what are pods, what are deployments, what are services, namespace, and how they fit together. I'll also be sharing a lot of resources so that you will be able to understand Kubernetes and try it on your own. We will be sharing you everything from the core concepts, the instructions to install Docker and Kubernetes, and how to try it out on your local machine, and then eventually we'll also share how you can run it on any cloud. So the other important thing which is very related to Kubernetes is YAML. You should have a good understanding of YAML, YAML. It's pronounced as YAML, and it is used for configuration files, and we will be seeing, we will be running various commands. kubectl, as you see here, kubectl is short form. This is a command line tool which controls the Kubernetes nodes. So we'll cover this in detail, and this is a very important command not only for your day-to-day job, but this is also important concept for clearing any certifications. So these are the certifications. So Kubernetes has a history. It started with Google, then it was handed over to Cloud Native Foundation, and which also takes care of Linux. So Linux Foundation is the parent organization, and Kubernetes is also managed as an open source project these days, within the governance of Linux Foundation or Cloud Native Foundation. They are same entity, within the same entity, and these are the certifications. So KCNA is Kubernetes Cloud Native certification. There is administration level certification and application developer level certification. So Kubernetes. So here I'll be giving you details about all these Kubernetes certification in coming slides. So just I'm taking you through these terms because this is there in the slides. So just if for curiosity you have these questions, so I'm just giving you some highlight about it. Feel free to share your queries on the chat as well. So let me proceed further. So here our goal is to give you as a beginner a good understanding of Kubernetes, the fundamentals, and you will also get a practical roadmap to start preparing for these certifications. And what are the strategies for these certifications? And in the next session, we will have a guest also who will be who has cleared all these certifications, and he will give you success proven strategies so that you will be able to crack this, and we'll give you a roadmap as well. So here, let's start. Let's dive into Kubernetes. So as I said, Kubernetes was first developed by Google, and it's now governed by Cloud Native Foundation. Now here Kubernetes is you can say a tool or a platform which is used for deploying, scaling, and running containerized applications. So if you're wondering what is containers, this we will be covering. Also, we will be giving you differences between containers and virtual machine in very short, but you would have understanding of virtual machines, and containers for now you can assume is similar to virtual machine. And virtual machine is an abstraction, or you can say that no, this is a technology. We will get into the details of that shortly, but it is helpful in running application. It provides isolated environment for running your applications in production in a very effective manner. So Kubernetes is building upon further on virtualization, containerization, and then it is a tool for container orchestration. And its name is sometimes also called as K8S because, as I said, there are 8 letters between K and S. So that's why in short form it's written as K8S. And Kubernetes is very popular container orchestration platform. If you have watched the trailer of this session, before the session begin, there was a trailer that contains a good video overview. It's kind of a nice video about what is Kubernetes, and it is explained in the form of graphical video, so easy to understand. I'll also provide link to that video so that if you have missed it, you can watch it later. This will give you some good idea about what is Kubernetes, but don't worry, as we will proceed, you will have more understanding of what is Kubernetes. So here, just for beginners, you can think of it's a person who is managing the logistics. So for example, nowadays you see a lot of items getting delivered from Zomato, Blinkit, Swiggy, something like that. A manager who is taking care of logistics of all the containers. Now here containers contain applications, not just some items. And if some failures happen, some demand increases, so it takes care of everything from routing, restarting, and scaling, and ensuring that demand is met. So this is an analogy, which is a tip for this slide. And also you should understand all the cloud providers support Kubernetes. So now if you have a question like why should we learn Kubernetes? Now we are in the AI era. So is really it makes sense to learn Kubernetes? The answer is yes, because our applications are running in Kubernetes, and with AI, when we will be creating more and more applications, definitely the importance of Kubernetes increases because your applications have to be running, and what all is mentioned in this slide about if the application fails or if it needs scaling, then definitely there is an orchestration platform which is required to take care of it. So this is about the importance of Kubernetes. So yes, with AI, the importance will be increasing, and in all the clouds, whether it is Amazon cloud, we have EKS service, which is a remote Kubernetes service, and then we have from Azure Kubernetes service AKS, and from Google Cloud we have GKE. So let's get into more details of each of these services. So one is Google Kubernetes Engine. Now this is an industry leading Kubernetes engine, and since Google developed Kubernetes, it is the most mature platform, and it has various special features like autopilot. So it has a lot of native support for multi-cluster management and advanced binary authorization, and it is having seamless integration with Google's global private fiber network. So these are some of the highlights. We'll also cover how to choose which cloud provider to use, but you should understand that these cloud providers help you in minimizing the overhead of running the Kubernetes platform. So if you are running it in local environment or in servers by yourself, you have to run the nodes. You have a lot of installation process. You have to run some containerization engine like Docker. Then you have to have various nodes. We'll see what all nodes are required to run Kubernetes, because Kubernetes is a distributed application. You will not be running it as a single component. You will be running as multiple processes, and different processes have different responsibility, which we'll be covering. So all the complexity which is there in running Kubernetes is taken care of Google, in this case of Google Kubernetes Engine, and same is the case with Amazon and Azure. So with these cloud providers, the task of running these containers and orchestrated by Kubernetes is further simplified. So here in this session, we'll be covering how to run Kubernetes on local environment, and the process for running it in the cloud environment will be very similar. The only difference is you have to point your cloud provider, you have to point your kubectl to the cloud provider, and there are sometimes tools which is graphical user interface tools. You have a web UI for running Kubernetes commands, so it further simplifies, and you can see also the processes running. So running on local system is more complicated, and running on the cloud providers is easier because you have more advanced tools. and only thing which you have to take care is the connectivity between your console, or if you are running through terminal, or if you are running through the web UI, then you have to ensure that you have right connectivity to these cloud providers. So autopilot is one of the most important feature in GKE, Google Kubernetes Engine, and you it's most advanced service. So you only pay for the pods you run. You don't pay for all the nodes. So this is a good feature of Google. Pod is something, it's collection of containers which are running your application. This we'll cover in detail in the coming slides. So let's move on. We have next as Azure Kubernetes Service. You have the Kubernetes environment hosted by Azure Cloud. This is a service from Microsoft. Again, it has enterprise grade security, and it integrates with Azure Active Directory. Azure AD is what it means with and it has capability of horizontal scaling and self-healing capabilities, which is there in all the service providers. So nothing specific about Azure. You definitely have integrated development tools. It has good integration with Azure DevOps. This was a DevOps platform for CI/CD, and then nowadays we have GitHub Actions, which is also another CI/CD platform. So when you are building an application, that means you are writing code. You can package the code after compiling it and run it using CI/CD automation directly into Azure service, Azure Kubernetes service, or AKS service. So this is what I mean with this point. So AKS provides quickest way to start developing and deploying cloud native apps in Azure. These are the advantages, which is it offers built-in auto patching, low maintenance operations, and deep ecosystem integration for full lifecycle management. But yes, when you have CI/CD tools, they can run with Azure, they can run with AWS or Google Cloud as well. So there is maybe very slight advantage with the GitHub Actions on Azure Kubernetes service. But yes, you can also integrate these CI/CD tools with any of the cloud providers. Now we have Amazon EKS as well, which is managed Kubernetes service on AWS. So this is very highly available control plane, and it is available in multiple availability zones, and it has deep integration with AWS services, which is access management, identity and access management service from Azure, from AWS, or virtual private cloud, or CloudTrail. So these are various AWS services. It has deep integration with your AWS services. So one of the important decision criteria for choosing your cloud provider for Kubernetes is based on your existing cloud provider infrastructure, from where you would like to integrate your applications with. So if you use the same host, definitely it is beneficial for you. So one important criteria, which is most important deciding factor, is if your entire application is running on say Azure, and if you want to migrate it to a Kubernetes based application, and definitely you will be having some proprietary technologies and tools, processes, which are the advantage you get from Azure. So you would like to leverage them, so you will use the same cloud provider. So if you have already an initial cloud provider, you will choose accordingly the Kubernetes service provided by that same cloud provider. But if you are building an application from scratch, there could be several other factors also, depending on what is the type of application you are building, which determines which cloud provider you have to choose. But yes, these are some of the highlights of various cloud providers of Kubernetes. So here, as I said, no, EKS also removes heavy lifting, and you don't have to manage Kubernetes by yourself. This is managed by Amazon for you, and you have to focus only on deploying the nodes and applications, and everything will be running in a secure manner as other cloud applications. Now, coming back to the certifications. So these are the certifications. So we saw that, okay, if you are at a beginner level, if you want theory-based exam, then you have Kubernetes and Cloud Native Associate exam. This is no exam which I don't see too much of value for job-related. It does not provide you that much advantage, but it's a good starting point. So if your organization is willing to sponsor you for this certification, I would say go for it, because it covers a lot of good cloud native concepts, which will help you, to understand things on theoretical manner. For senior role, it is important. For an architecture role, you will understand the big picture of cloud native, why it is important. So that's the starting point for the certifications. But to get job ready, so if you are a developer, the one which is most developers they will start with is CKAD, Certified Kubernetes Application Developer, and this also has hands-on lab, and this will focus on deploying and debugging apps which are running on Kubernetes. And you have to understand two things. One is YAML, and the other thing is kubectl command. These are the two most important part of the certification exam. So basically, here just by watching video or learning concepts, reading books, this will not help you. You have to have hands-on experience, because you have to be very fluent with the kubectl commands, the different options. There are different verbs. We will cover that in next few minutes in the later part of this session. But yes, YAML data serialization language is also very important. So these two things are very important if you are appearing or you are planning to prepare for certified Kubernetes application developer. And then if you are a DevOps professional, the one you can go ahead with is certified Kubernetes administrator certification, and this also has hands-on lab, but instead of deploying and debugging, it will focus on operations, cluster operations, which includes how would you scale, how would you take care of various issues, for example restarting, upgrade, and this is mostly troubleshooting heavy. You have to learn about troubleshooting Kubernetes. So this is about various certifications which is available. There are certifications for security professionals as well. So I'm not covering that, but yes, you should be aware if someone is a security professional, I would recommend him to share in chat the queries, or just let me know. I can share the roadmap on need basis for security professionals as well. So I think all good. Just let me see if there are some queries. Then we'll deep dive into further concepts. related to Kubernetes. So now coming to Kubernetes fundamentals, so we got now the big picture first on Kubernetes. We looked into various cloud providers. Now let me look into the fundamentals. So we'll start with what is container, how it's different from virtual machine. We'll look into the architecture of the Kubernetes, also how the architecture of container is different from architecture of virtual machine, and what is container orchestration. And then we'll also cover most important concept, which is about the pod. So let's look into the virtual machines. Virtual machine, these things you would be familiar with. That virtual machine is kind of abstraction on a physical machine, and it runs their own operating system. Virtual machines are heavy. That means they are large in size. They can be GBs, of size. And then definitely it will be slow to start, because if you have a Windows virtual machine or any other virtual machine like Linux virtual machine, it will take the complete boot time to start, and then your application will be started. So for example, if suppose you are running an application which is a web application which also has a database, then if restarting the virtual machine will mean starting the operating system, booting the operating system, and then once the operating system boots, then your application server will also start and your database will also start. And then once every component is running, then only your application will start functioning. So this is about a startup time of virtual machines. Now containers are different than virtual machine. They share the host OS kernel, so they don't have their own operating system. They share the operating system of the host. So now this makes them lightweight. They can start in seconds, and their size is also small. Instead of GBs, it's having MBs of size. And these containers are the things which is being orchestrated by Kubernetes. So this is basically what you should understand. Containers are lighter VMs. They have isolated processes. They share the same kernel. The operating system is shared across different containers, and that's why you can run many containers. And in nowadays in microservices based application, say for example, if you have an e-commerce application, you will have multiple microservices, maybe tens of microservices. You would have product catalog microservice, you will have shopping cart microservice, you'll have payment processing, you'll have a microservice for order processing, shipment, you may have a notification service. So you see that now there are so many different services, and each of these services will have their own database. So you may be running many containers. So all these components, if they are running in different containers, managing them manually will be very complicated task. And Kubernetes is the tool or an orchestration platform which can manage these multiple hundreds of containers, tens of containers, or even thousands of containers. So this is about Kubernetes, how it relates to virtual machine and containers. Now, if we look into the architecture of virtual machine, you have the hardware, which is the physical hardware. So if you have any server, you will have an operating system on that server. And then there is a spatial software which is called an hypervisor, which will be running on that operating system. And then on top of it, you may create multiple virtual machines, and each of the virtual machines may have guest operating system, and each of the guest operating system will have some application running on it. So one important advantage of virtual machine It's traditionally used for running multiple operating system on a single machine. So if in earlier days, if you remember or recall, if you would want to run Linux and uh, Windows on the same machine, you would need some virtualization software, and then with the help of virtual machine, you'll be able to run two operating systems on the single device. Same is the case if you are running Windows on Mac as well. But nowadays, things have become more advanced. Windows do include a a Linux container by default. So now operating system have this hypervisor or some capabilities of it already built into it. So things have optimized a lot. But yes, in earlier days, this was the case. So you had very heavy virtual machines, and there was an overhead also, because hypervisor has to take care of all the abstraction with the hardware or the host operating system, and the performance that you get in virtual machine is not that if you are running some operating system directly on a hardware. So now coming to containers, containers are, as I said, so you will have a physical machine, and on that we have a host operating system. The kernel will be shared. Then you have a container runtime. Container runtime, one of the most common is the Docker container runtime, and then on each of these containers you will have different applications running. So if you see, there is most of the component like host operating system, kernel, and the container runtime is shared. So your size of a container is reduced, and you can run many more containers on a machine than many virtual machines. So now coming back to what is a cluster and what is Kubernetes. So Kubernetes is, as I said, is a distributed application. It's not a single process. It is a collection of processes, and each of these processes would be running on different nodes. They can run on the same node as well, but yes, they may run on different nodes as well. So that's why we use the term cluster. So basically Kubernetes, when we say we are running Kubernetes, we mean that we are running Kubernetes cluster. So now coming back, we have two things for a Kubernetes cluster. One is the control plane, other one is the worker nodes. So the control plane is comprising of the API server, the scheduler, and there is ECTD. Now this is a key value store. So it just it stores various settings, environment variable. So you can see control plane is the brain of your Kubernetes cluster and decides what to run where. So it has API server, it has a scheduler. On the other hand, there are worker nodes. Worker nodes are the nodes where your code is running, and you will have kubelet. Kubelet is an agent on each node which will talk to API servers, and it runs containers. And then you have pods. Pods are wrapper around your containers. They are the smallest unit of scheduling. And then you have a kube proxy, which is handling the network related rules, so your services can reach different pods, and they could. So kube proxy takes care of the interconnectivity between various services or nodes or pods within Kubernetes. So let's look into further details. So we have control plane components. Control plane component contains, this is the component diagram. So you have API server, ECT, scheduler, and then you have on the other hand kubelet, container runtime, and pods. So pod is the smallest deployment unit in Kubernetes, and it can comprise of one or more containers, usually one main container per pod. Then you have shared network and storage. Containers in a pod talk via localhost, and these are pods are ephemeral by design. So that means that they may crash, they may get reinstantiated, they can be replaced very quickly by the Kubernetes runtime. So you can't rely by having their IP address, you can't harden the connection with the pods. Pods are something which will be coming and going very frequently. So these are some of the core concepts. So pods, as I said, is the containers, one or more containers which you can deploy. And deployments, these are all configuration. So deployment services, namespaces, these are the objects that you have to be very clear about what they are in order to clear the exams. So this is a very important point. So if you go through this session and these slides, and so most of the concepts of the exams are covered. And as I said, the exam is more on the practical side, not on the theory side. So if you understand these concepts, which I have collected in these slides, most of your preparation is done. What you have to do next is build speed and build fluency with the tools by doing more and more practice. So just I'm kind of running through these concepts because these are very important for your exams. So pods, as I said, one or more container, the wrapper around it so that you can schedule it, you can deploy it, and they can be replaced, they can die. So this is a very dynamic entity, and you will rarely create it directly in production environments. It will be created by your runtime. Deployment is a configuration where you declare the desired state for pods. So you should understand that Kubernetes is declarative by design. That means you don't have to define how you will be taking care of the pods, but you just declare that this is the desired state. I need these many containers or pods running in my system. These are the dependencies. So you share your desired state in configuration, which is done using YAML. YAML is what I referred earlier in this session, which is very important. And all the entities, all the objects which I'm talking about, like deployment, services, they have a corresponding YAML which represents it. So you don't write code here in Kubernetes, you just write configurations in the form of YAML file. So that's why YAML is very important. I'll also share a free Udemy course on YAML, and I will also share you some good resources about YAML. So stay in this session, we'll be covering them. Now we have something called rolling updates and rollbacks. So rolling update is about updating your application without making it down. So if your application is running in 2 containers, so what does rolling update means? That if you want to update your application, and if this application update requires a restart, then this will be not done at all the containers in the single time. In the same time, it will be done one by one. And rollback is something like if the upgrade is not giving you the desired result, it is creating regression, or your application has started failing because of some new code which has introduced some side effects. then rollback can put it back to the previous stage. So this is a feature which is available by default in Kubernetes. So rolling updates and rollbacks, these are the two important features which you get out of the box with Kubernetes. So now you will understand and appreciate the advantage of running your application in Kubernetes. So for those who are wondering, why do we need Kubernetes to run your applications, and why and what are the advantages of it, then this is one advantage, like you get rolling updates and rollbacks. And then you can ensure replica count is always met. So this is another important feature, that if you want replicas or redundancies, so if same service you're running in multiple instances, then definitely if one instance crashes, your service do not go down. So I gave you an example of e-commerce service, and if you have a say payment service or shopping cart service, and it's running on multiple instances, definitely these instances will be accessed via load balancer. And if one service instance crashes because of some problem, maybe memory overflow or some code which has thrown some exception, then other instances will not be affected, and the load balancer will be routing the upcoming traffic to the other nodes which are available. So this is reliability advantage of applications running on Kubernetes. And you can ensure that minimum replica count is always met in a declarative fashion using deployments. So basically your workload object is the deployment. So basically you will create a deployment, and deployments will manage the pods for you. This is important concept you should remember for the exam. So now let's talk about the services and namespace. Let me talk about namespaces. Namespaces are cluster or virtual cluster inside a cluster. They separate the dev, staging and production environment. They can apply quotas. Quotas could be with respect to the storage, the memory allocation, and it could be also providing you policies on these clusters or virtual clusters per team. So if you don't specify a namespace, then you get the default namespace. So namespace is for organizing your clusters into different environments, for example dev, staging, production, so that you can apply quotas or policies on them separately. Now services are something a stable address in front of a moving target. Moving target is what is pod. Pods are ephemeral, and this service is the access to the pods. So basically you can think of service as an interface to the pods. Pods are internal only. They can talk to each other using cluster IP. But yes, service is something which will expose it to the outer world. So basically you have a port when you have a service, and this port is exposed externally through service. So it makes you available services, making a pod expose externally. So if you're running some service, for example, if your service is running some REST API, you will have to access the microservice, for example, the product catalog service via the service. So here is an example of the YAML. So if I'm creating a pod, so you will provide what is the API version, then the kind, whether it's a pod. Then you see here the metadata. Metadata is the name which is provided for reference to the pod. and then spec and then containers. So this is what is running inside the pod. So here, if you write this code, this will run a Nginx container. Nginx is a simple HTTP server or a proxy server which can serve your web pages, static web pages. So if you are hosting a site and it has some static web pages only, then this YAML is good enough to run a pod, and automatically a Docker container with the image Nginx will be instantiated. So it's very handy. Once you understand the commands, you can run the kubectl command, and this pod will get instantiated. So I'll share the commands later. I'll also share a video which will describe all these stages step by step. So yeah, again, these are important slides you should keep, and the most important part of the session is this kubectl command, and this command is covered in this particular slide. So pay attention here. This is the first command, kubectl get pods. This is of inventory check. It will list the pods in your current namespace. Then you have kubectl apply -f file.yaml. So it will apply and create the instance, whether it's a pod or a service, a deployment based on whatever is the content of a YAML file, and it will apply it. That means it will run it, create an update from a YAML file. So if the pods are already running, it will update. Otherwise, it will create. And then there is a command called kubectl describe pod name. So generally you will use kubectl get pods, then you'll get the list of pods, and then you can describe pod name, and this will give you the status of each of the pods. So if you're running some rolling update, or if you want to see a troubleshoot, you use this command kubectl describe pod. So this is again very important command for the exam. This is for describing the status. If there are errors, then it will be able to point out to errors. And then there is kubectl log spot, again important troubleshooting command or debugging command. It will give you the container output. So this is about so now I'm taking you through MiniKube. So MiniKube is a single node Kubernetes service which you can run on your laptop. So if you're running some application, if you want to run some production grade application on some cloud provider, definitely because you would like to keep it available 24/7. You would also like to run it all across the globe and in a very reliable, secure manner in high availability mode, then you have to use some cloud provider, which could be AWS or Azure or Google Cloud. But before you deploy something on the cloud, you would like to test it, right? Because when you run on the cloud, you will start getting charges for it. And if it is not available, you will be losing money. The effective way is to first test your Kubernetes clusters on your local laptop. So you have a command called, you have a tool or a single instance, single node Kubernetes environment, which is called MiniKube. I have a detailed video about how to install MiniKube as well. I'll share to all of you. So in the description, you will find all the details. And then with the MiniKube, you will be able to run kubectl commands. And this is the command line interface for interacting with any Kubernetes cluster. It could be a remote cluster or it could be a local cluster. So the first command is kubectl run nginx image equal to nginx. So this is one container simplest possible workload. This is most of Kubernetes examples will be showing this. So I have already done a demo of this in the previous session, so I'm not doing it. But yes, MiniKube you can install on your laptop very easily. I will provide the link to install MiniKube. You have to just run few commands, and within few minutes you will get the MiniKube up and running. But definitely you need to have Docker installed as a prerequisite. So I will also share how to install Docker. So if you are running Mac or Linux or Windows, you will have specific instructions for installing Docker. So that's important steps which is required to install Kubernetes. So here creating a deployment, kubectl create deploy web image nginx replicas 3. So this command, you see, I'm creating a cluster where I'll be having a deployment, and I have put this replicas equal to 3. Now here important thing is I'm not using configuration here. I'm directly using command line. So you would have more rules. So then you will transfer all these settings to a configuration file, which is a YAML file. But yes, for demonstration purpose, these are the commands. You can just install MiniKube, and once you have it, you paste these commands from the slide, and this will be sufficient for you to run and see the output of these commands. So this covers are all the core concepts of Kubernetes. And now I'm coming to the format of the exams, which is first one is cloud native associate exam, so which has multiple choice questions, 90 minutes. You will have cloud native concepts. I have also covered all the cloud native concepts in my separate videos previously. So I can also share the link of all these cloud native concepts. You should also learn Kubernetes basics, which I have covered in this session, almost all the basics. So this slide and the session will be useful for you to clear KCNA exam. And there are some concepts which are related to observability or monitoring of Kubernetes clusters. So that is some we have covered. For example, how to view the logs, how to describe a Kubernetes cluster, see how many cluster, how many pods are running. All these details are around observability. The other exam which is good for developer is Certified Kubernetes Application Developer, CKAD, and this is hands-on lab, 2 hours. Here you will be building, deploying, debugging applications. You will be creating configurations. You will be creating multiple container pods. So for example, if you have a service, if it needs a database and an application server, you may be running these 2 components, database and application server, on different containers. So your pod will be containing different containers, one for the database, one for the application server. You may have many more as well. If you have a cache, then you may have 3rd container. So that is how you will design your application. Then we have a certification CKA, which is again a hands-on lab. It has 2 hours duration. It is focused on cluster installation, networking, storage, and troubleshooting. So if you are a developer, basically application developer, then CKAD is important. For beginners, any beginner, whether he is a platform engineer or site reliability engineer or DevOps engineer, CKAD exam is important or certification is important. So this is about the comparison of different certification exam. Now you can't pass these exams just by watching videos or listening to sessions or reading books, because memorization is something which will not help you, because you will have a scenario based questions and you don't see the same questions getting repeated. So hands-on is mandatory, and your speed is also important, because in 2 hours you have to complete 15 plus tasks. So this is important. So timing is important. So yeah, this is what we will be covering in the next session. We will be doing hands-on and we will be timing the task as we will be covering. So you will see that what is the mastery required to have a hands-on fluency of someone who has successfully cleared these certifications. So generally, how much is the days required to prepare? So if you want to clear the Kubernetes application developer exam, you may need 30 to 45 days. You should consider 45 days. And this means you are studying 2 hours a day. So if you are practicing 2 hours a day and you do this every day, so this is important, because then you will be consistent. If you are just studying on weekend, that's also another approach. But yes, then you have to spend more effort. So either you do 2 hours study on all the days, or otherwise you can do maybe 8 hours on both the weekends, Saturday and Sunday. And then you'll not have time to relax. So preferred approach is study on weekdays, maybe in smaller chunks, 1-2 hours, and this way you'll be good in a month or maybe 1.5 months to clear the application developer exam. And if you want to clear the administrator exam, it's more detailed, so you may need 2 months or maybe 2.5 months to clear the exam. But the same schedule you can follow. We have a list of Udemy courses. We have list of videos which I will be sharing in the description of this video, which will help you, which will guide you from everything, understanding what is Docker, what are containers, what are virtual machines, all the cloud native concepts, how to install Docker, how to install Kubernetes, MiniKube, and how to connect to these MiniKube, run kubectl commands, deploy a microservice, manage the microservice, do rolling updates, do rollback, do configuration, defining replica set. So all these concepts will be covered, and I'll be sharing the videos in the description right after this session. So you may visit this space again. And yes, this is no important thing, that consistency beats intensity. So practice kubectl commands daily. And then I'll also be sharing articles. So if you don't want to watch videos, there are detailed articles. I have published articles on these important topics on Kubernetes, which I'll be sharing. I'll also share some of the books and courses on YAML as well. And this will enable you to clear both these certification exams, which is application developer and Kubernetes administrator exams. And definitely stay with us in our next session. Stay tuned. So subscribe to our channel, and when we will be sharing our next session, we'll be doing hands-on on Amazon cloud. So here, these are the final tips. Just as a takeaway, you can take a screenshot of this, and then this will be our closing slide. So I'll just quickly skim through. So here Kubernetes is a platform for orchestrating containers, and it is provided by all the cloud providers, whether it is AWS, Azure, or Google Cloud. The concepts are the same. So it's not that there are different concepts for Azure from Microsoft, or it's a different concept on Google. Most of the concepts or mental models are same. So if you learn Kubernetes on one cloud platform, you'll be able to apply the concepts on the other cloud platform as well. So pod is the smallest deployable unit, and then we have other Kubernetes entities, which is deployment, services, replica set, and these are all built on top of pods, because pod is the fundamental object in Kubernetes. Mastering YAML is very important because Kubernetes is a declarative platform. Here you don't write code, you just define configuration, the desired state, and the platform will ensure that your desired state is met. So you define policies, and these policies are documented in YAML, and you will need these YAML to run or apply the pods and instances which you run on Kubernetes cluster. And kubectl is the command which you will be using to connect to Kubernetes cluster. And there are some important verbs like get, apply, describe, and logs, which I showed you earlier, that these are like 80% of your task for managing Kubernetes is done through these commands. So it's very important. And if you are very fluent with the command and different options and verbs, then very easily you can clear. So that's why 1.5 months of practice is good enough for clearing the application developer certification. Choose your certification. Now I have described all the certification in detail, so you should be able to choose your certification depending on your role. And finally, hands-on practice is very important. I will share all the details about the hands-on practice, and in the next session we will show you the hands-on on all these topics which we covered today. So thank you. This is entire thing, all the content which I wanted to share to you. There was slight change in the agenda because the guest got some emergency, and he'll be available next week. So we will be taking up the part of running it live and doing a hands-on of the session in the next session. Thank you everyone. Thanks for watching, and wish you all the best, and stay connected. See you.